Hello, everyone, and welcome to the May edition of the Virtual Planetarium with my friend and colleague Pete Lawrence and myself, Paul Abel. And as ever, we will start with the solar system and work our way out to the stars. The solar system is going to take slightly less time than it did in the April edition. Let's start with Mercury. At the start of the month, May sees Mercury at magnitude 1.2 on the first of the month, but it rises only half an hour before the sun, so it's not really good for viewing.
No.
We do have a 5% lit waning crescent moon just 2.5 degrees from Mercury, which will be at magnitude plus 0.8 on the 6th of May, but again, that's quite poorly placed before sunrise. So not much changes for the rest of May. Mercury rising just 35 minutes before the sun on the 31st of May, although it's a pretty decent magnitude at that point at minus 0.7, so a bit brighter, but on the whole, not ideal.
Not ideal. Okay, well, let's have a look at Venus, see if we get anything better with that. Well, Venus is currently a morning object, but too close to the sun to be observed safely. So Venus isn't any better. Mars is improving, actually. So I'm not going to be negative about Mars, but it isn't a good display of Mars at the moment. It's Mars and Saturn aren't well placed in the morning sky. You may just catch a glimpse of magnitude plus 1.1 Mars in the morning sky at the start of May, the planet rising an hour before the sun on this date. The problem is this doesn't give it much opportunity to gain any altitude before the dawn twilight gets too bright to be able to see it. You might have a better chance of seeing something on the morning of the 5th of May, where Mars is accompanied by a 12% lit waning crescent moon. Both objects will have risen by 4:40 BST, that's 0340 UT, the moon 1.4 degrees east, that's below and left as seen from the UK, of Mars. By the end of the month, having brightened by the narrowing amount to just shine at magnitude plus 1.0, Mars rises 100 minutes before the sun. Your best bet to finding it is to use binoculars around 0400 BST, 0300 UT, when Mars can be found around 6 degrees above the eastern horizon.
Practically overhead, please.
I don't think you can get away with that one here.
No,
the reason why they're getting bad at this time of year is that they're really close to the sun, and we're getting close to the June solstice, which means that if they are improving by getting further away from the sun, the June solstice is wiping that out. And the opposite effect will happen after we've gone past the solstice. They will get really good really quickly. So don't give up on the planets.
No, particularly Mars and Jupiter will pull away from the sun quite quickly. And
they will
be very, very good targets later in the year. They'll be very well placed from the UK. So
yes,
plenty to look forward to. And on the subject of Jupiter, it reaches superior conjunction with the sun on the 18th of May. So can't be seen really that well this month. It is worth noting that magnitude minus 3.8 Venus will lie 11 arc minutes from magnitude minus 1.8 Jupiter at around 0900 UT or 10 o'clock BST on the 23rd of May. But both planets are barely more than 3 degrees away from the sun. That conjunction isn't really going to be a viable one to observe.
No, it's not. I would balk at that. And I have actually observed Venus 2.5 degrees from the sun, but it's extremely dangerous and you shouldn't attempt it unless you really know what you're doing. I don't think it would be worth it. I think you would probably struggle to see Jupiter that close to the sun.
Yeah, I think the brightness and the glare would be too much. Saturn, as Pete has mentioned, is it's loitering around in the morning sky and isn't going to improve much this side of the solstice. But we will begin to see some rapid improvement in Saturn later on after the June solstice. Uranus, I'm afraid, lost in the evening twilight at the start of the May and is in conjunction with the sun on the 13th, so that's not visible. Neither is the planet Neptune, although it's visible in the dawn twilight. The twilight is still too strong to be able to see it.
Yeah. Okay, well, let's look at something a bit more positive. Although this isn't great either, to be fair. I don't want to give you false hope here, but the Eta Aquariid meteor shower reaches peak activity. It's predicted to reach peak around 2200 BST on the 5th of May, when the radiant will be well below the horizon. So that means the best views for the UK will be in the couple of hours in the run-up to dawn on the 6th of May. The moon conditions are favourable this year, but it's a difficult shower to observe from the UK because it's really better from more southerly latitudes.
Yes, but it's still worth trying for, because you still do get the odd bright Eta Aquariid meteor, and as all these things, we never quite know what's going to happen, so that's the point in observing them.
Absolutely right. Well said.
On the 10th of May, now, we do have good circumstances for observing the crater Humboldt, which is a huge crater, some 200 kilometres in diameter, and it lies in the libration zone on the moon. Now, the moon's only ever displays 50% of its face towards us. The other side is permanently not on show, the dark side, the night side, as we perhaps call it. But that's not the whole story. Because the moon rocks a little bit on its orbit as it goes around, it is possible to see around the other side of the moon by about 9%. So you can actually see a total of some 59% of the lunar surface in total from the Earth, although never any more than a total of 50% at a time. So this is a crater that isn't visible that often, and it's worth visiting.
I think it's always there, but it's just not always well presented. It's really foreshortened a lot of the time, but when you get a good view of it, when it sort of swings back in towards the centre of the moon, it's extremely rich in features. It's got loads of dark patches on its floor and cracks on its floor and other craterlets to look out for. It's a beauty, actually, if you can hunt it down. If you get the Terminator nearby, it's absolutely fantastic crater to see.
It is, and it's such a shame it isn't further or more on the centre, towards the centre of the moon.
Yeah,
because it would be a spectacular sight, and probably better than Tycho or Copernicus or any of the one of the craters we regard as the standard brilliant craters to see. The amount of detail you'd be able to see in Humboldt if it was closer towards the Earth side. But there we are. It's not, but it is always visible, as Pete says, but it is best seen when those libration zone that it lies in is tilted towards the Earth. Yeah.
Okay, so we'll stick with the moon. On the 14th of May, the moon, as it approaches setting around 0200 BST, 0100 UT, will be 35% lit in its waxing crescent phase, and it will sit 2.3 degrees north of the Beehive cluster, Messier 44, which is always a nice sight. If you've got binoculars and you can pick that up, you should be able to pick up the cluster stars. But then on the 17th of May, there is an interesting phenomenon to look out for. I don't know if you've ever observed this, Paul. It's when the crater Plato's a large crater, large circular or slight elliptical, I suppose it looks to us, because it's slightly foreshortened crater on the northern edge of Mare Imbrium, between Mare Imbrium and Mare Frigoris. The crater has got a sort of flattish floor, which is covered in lava, obviously, and the edge of the crater is quite rugged. And at certain times you get a peak which casts a triangular shadow across the floor. Now, it was observed by Patrick Moore and Percy Wilkins, I believe, and it was right at the end of their observation session. They recorded the shape of this shadow, and they recorded it as curved rather than straight-edged. You'd expect it to be straight-edged. And there's been a lot of controversy about whether it is actually curved, whether they got their observations right, or whether they were being fooled by something, or what was going on. Looking at it in detail, there looks like there's a sort of debris area to the where would that be? The southeast inner edge of the crater, and it's possible that the shadow falls on this and it creates the illusion of having a curved inner edge. So that's something interesting to look out for.
Well, there's a couple of circumstances about that observation, actually. So I have seen Plato's hook, and it's always looked straight to me. But it's worth noting that when Patrick and Percy Wilkins made that observation, they were using a 33-inch refractor at Meudon in Paris. So it wasn't a standard, amateur astronomer's telescope. So it's not unreasonable that the shadow may have had more detail in it than you would normally see with telescopes. Although, having said that, you would certainly expect people using imaging techniques with large telescopes to be able to pull that out with it if it was there, unless it was just such a precise alignment of libration and shadow that it's such a very, very rare effect. I don't know. I don't think the mystery's completely closed on that.
No. I'm pretty convinced it's the sort of debris scree field which is next to the rim, which is causing an optical illusion when the shadow falls near it. But if you want to look out for Plato's hook, it should be visible around 0235 BST on the morning of the 17th of May.
So that'd be a good one to look out for. Can you see if the shadow is curved? Answers on a postcard, please. Okay. Also on the 17th, minor planet 2 Pallas reaches opposition, shining at magnitude plus 9.0 in Hercules. So binocular object, if you want to track that down.
Yeah, probably a small telescope, actually, would you not think? Unless you've got big binoculars.
Yeah, you're probably right. It's not only that, the stability that a telescope provides probably makes it much easier to find it.
Yeah. Towards the end of May, of course, we are starting to head into Noctilucent Clouds season. So from about the 21st onwards, there's no strict date on this. It's just luck of the draw, really. That's the beginning of Noctilucent Clouds season. So it's worth going out and trying to observe Noctilucent Clouds. Now, I know it's become a bit of a sport to take photographs of them and, put them up and say, wow, they look wonderful, and be a bit disappointed if they're not there. But actually, the negative observations are just as important as the positive observations. And the reason for that is that there have been various conjectures and theories put forward that solar activity promotes or suppresses noctilucent cloud formation. So if you get lots of negative reports and you've got a clear night, that's valuable data to either support or dispute such theories.
Yeah, so as ever with astronomy, not seeing something because it wasn't there is just as important as making the actual observation. And it'll be interesting to see how the Noctilucent Cloud season develops. It wasn't a particularly strong display last year, was it?
No, it wasn't.
As I recall. And so maybe this year will be better. We'll just have to wait and see. On the morning of the 24th, the full moon will occult the globular cluster Messier 4 before heading to a position 33 minutes due south of Antares. This is in the constellation of Scorpius just before setting. So that'll be quite an interesting one to watch out for. I don't think I've ever seen the moon occult a globular cluster before. It'd be quite low down.
Quite a lot of timings to record in that one.
It would, but worth trying if you can get it.
I don't know what that's going to look like, actually, because the full moon will be really bright, obviously, and the globular cluster will suffer with the moon's glare. But of course, if you're using a telescope, the stars should stand out even though the moon is full next to it. So it will be really interesting to see whether anybody gets any observations or photographs of that particular event occurring.
Yes, absolutely. But it'd be worth doing. And if it's clear, I shall certainly try a visual observation to see what can actually be seen with it. Okay, well, the night sky. Let's return to the night sky, see what we have now. Well, summer isn't far away now. As we were saying, the June solstice is getting closer. And as a result, the nights are getting noticeably shorter. Although this is good news for solar astronomers, for those of us interested in night skies, this means our window of observing is quite reduced.
Yes, it is.
The most noticeable star high on view in the southern part of the sky, certainly early in the hours running up to midnight. It's the bright orange star Arcturus in the constellation of Boötes, the herdsman. And as Pete often reminds us, it's the brightest star in the northern half of the night sky. I don't know why I find that fact so amusing. I think it's because it's preceded by northern half, so not even the whole of the northern hemisphere, just the northern half of it.
Well, I suppose it's born about by having written about stars for many, many years, and there are lots of pitfalls you can fall into. For example, if you say you talk about Sirius, you say it's the brightest star in the sky, people will go, it's not the brightest star in the sky. The brightest star in the sky is the sun.
Yeah.
So you have to qualify that and say it's the brightest nighttime star. So if you're talking about Arcturus, it's not the brightest star in the night sky, it's the brightest star in the northern half. So that's the half of the sky which is divided by the projection of the Earth's equator into the night sky, which forms the celestial equator. Sirius is south of the celestial equator.
Yeah. Okay, that's fair enough. It's good to always clarify these things. The thing about Arcturus is the colour. I always find, even in a twilight sky, actually, the orange colour of Arcturus to be quite striking.
Yes, it is.
Arcturus literally translates as bear guard or guardian of the bears. And this sort of gives a clue to the sort of herdsman Boötes actually is. Presumably he was busy spending most of his time herding bears, which must presumably be harder than herding cats. I'm not sure, but
I don't know. Probably equivalent, I should think. It's got a lot of different mythology, Boötes. I think he was attributed with the invention of the plough.
Right. Okay. How?
So in modern terms, perhaps he's attributed with the invention of the saucepan. No, I don't think that's correct.
Okay. Or the question mark.
Or la casserole.
Yes,
okay.
yeah.
So the constellation of Boötes is distinctly kite-shaped, and impressively the kite appears almost at the right way up at this time of year. If you look above Arcturus, it sort of spreads up from there, and it's about as high as the length of the saucepan. That's the best way to think of it. But there are some nice stars in Boötes as well, aren't there?
There are indeed. Epsilon Boötes, or Izar, this is the left-hand star in the kite shape, is a beautiful yellow-orange double star. Now, although the separation is quite wide, some 2.8 arc seconds in separation, they are magnitude 2.9 and 4.9 respectively. So that can be a bit of a challenge for smaller telescopes, but they do look, they are worth it, and the colour in particular is quite pretty.
Well, if you keep going up, you'll reach the widest point of the kite, which is marked by the two stars Delta and Gamma Boötes. Finally, at the top of the kite, that's marked by the star Beta Boötes, or Neckar, and the star just off the left-hand shoulder of the kite is Mu Boötes. And that goes by the rather wonderful name, I always like this name, of Alcalurops.
Well, that's an interesting. What does it mean?
I have no idea.
You see, you should have prepped.
But that's a nice double, actually, Alcalurops.
It is. It's actually much easier to see because the separation of the two stars is 108 arc seconds.
Yes.
So much easier target. If we look to the left at the widest part of the kite shape in Boötes, we've got this rather beautiful semicircle of stars, and this forms the constellation of Corona Borealis, the Northern Crown.
Yes.
The brightest star, Gemma, shows a small amount of variability, actually. It varies between about 2.2 to plus 2.3 over a period of 17 days, so slightly variable.
Slightly variable, yeah.
But there is a much more variable star in this constellation, and that is the famous star Arcturus Borealis. This is
the dust puff star.
The dust puff star, yes. It's a huge yellow supergiant star. At its brightest state, it's quite bright at magnitude 5.7, which means if you've got a really dark sky and it's clear, you should be able to see it with the naked eye. But when it shrinks down to its faintest magnitude, it drops to a massive 9 magnitudes lower, around magnitude 15. And even a 12-inch telescope will struggle to pick that up if you're just using your eyes. So that would be quite... So
it's quite remarkable,
a drop.
Actually. Yeah, and the really good thing about Arcturus is the fact that it's in the semicircle of Corona Borealis, and there's not anything else there you can see. So if you can see a star in the semicircle, then that's R. And we can't tell you when it's going to be bright or when it's going to be dim because it's an irregular variable.
Yeah, there are some predictions on this, actually, and I believe the current predictions are that in the early to mid part of 2024, we expect this star to undergo a brightening. So this is a constellation to keep watch out for. And if you see a bright star in the centre of that constellation, it means that our Corona Borealis has finally undergone a big brightening event.
Because it does, sometimes it stays very dim for a long time, doesn't it?
It does, quite a long period of time. It's quite an unusual star. It's very, very interesting, and one of the ones I enjoy keeping an eye on.
Oh, right, okay. If you return to the bright star Arcturus and Boötes and you draw a line from it through the centre of Corona Borealis and on for the same distance again, you'll arrive at the distinctive, but actually not particularly bright, asterism known as the Keystone. And that's part of the constellation of Hercules, the strongman. A rather ill-defined group, I have to say, of not terribly bright stars, which occupies a large area of sky in that region.
It is, although I think it's like a number of these constellations that aren't particularly bright and striking. Once you've seen them, they just stick in your mind where they are. So once you've identified it, you shouldn't have too much trouble identifying it again.
Well, you've been observing for a long time. I mean, and I have as well. And with Hercules, I see the Keystone, and you just see the sort of other stars sort of flailing around the outside of it.
Yes. But it's actual fact. So the Keystone does look like the torso of a man, but in fact it's
even though it isn't.
Yeah, that's right. It's upside down, and I still don't understand that to this day, because it does look much more like a human figure with the Keystone forming the torso than having that upside down. So I do find that a bit strange. But the Keystone is a good way to find a very nice object that we've often mentioned in the virtual planetarium. If you go about 2/3 of the way up the right-hand side of the Keystone, we have a very spectacular globular cluster. This is M13, the Great Cluster in Hercules. So this is a vast collection of stars, so anywhere up to probably about 1 million stars, all crammed into a spherical volume just 145 light years across. So if there are any planets in that globular cluster, nighttime would come very rarely indeed. It would be quite a spectacular sky if you lived on a star in M13.
Be quite interesting, wouldn't it? I mean, if you had a planet in the centre of the globular cluster, they'd probably have a completely different idea of what the universe was like compared to us.
Yeah, you'd probably get all sorts of interesting philosophies and things arising from a very different night sky. If you look at how the night sky kind of has influenced human thinking over the years, having something like that in the night sky would really be quite striking.
It would. You'd never get any sleep either. The interesting thing about M13, of course, is if you observe it and you photograph it, is that there are 3 distinctive, fairly weak, I have to say, dust lanes in it, but they join together at a central point, and they're arranged at 120-degree intervals, and they form a feature which is known as the propeller.
Right.
Stands out fairly well, actually, the propeller.
Well, you say that, but I've looked at M13 in I don't know how many telescopes, from small 4-inch to a massive 20-inch telescope, and I've never seen this propeller. So I think
you're not very good. The
I think it's a figment of your sleep-addled brain.
No,
I'm not convinced about this at all.
Sleep-addled brain. The propeller in M13, it's what I can always identify it. When I see a photograph of M13, or a photograph of a globular cluster, I can always identify M13 by the presence of the propeller. And I can always tell the depth of the exposure by how close the propeller is to the edge of the globular.
Okay.
Because it actually sits quite close to the core, and there's much more of a globular beyond that than many people actually capture. They capture the core region of the globular most of the time.
Yes, okay. I'll take your word for it. Okay.
It's a little project for you for 2024 to see the propeller.
I've been trying it for the last decade since you've been banging on about it, so I don't. But I will try once more and see if I can.
I'll help you.
I'm sure you'll be a great help. The 6-inch telescope will actually start to resolve stars around the outside of the cluster. In actual fact, it's not just a 6-inch telescope. I remember once looking at M13 with a 4-inch refractor. a very, very dark night, and you could see stars on the very outer periphery
Yes,
of
you can.
M13 being resolved. So you can actually see it, some of the fainter stars with
They're
small
quite
telescope.
interesting, aren't they? Because there's a lot of descriptions of globular clusters actually say you can resolve all the stars into the core.
Yeah, I'm not sure about that.
That's not true.
No.
What you can see are the stars in this spherical arrangement. You can see the outer ones which go across the core, but the core itself is so densely packed that to actually resolve it in most cases, it would be impossible with amateur kit. What you're seeing is the glow, and you're seeing the outer stars superimposed on it.
Yeah, and you can tell this actually. Globular clusters, particularly M13, often tolerate quite high magnification if it's not too bad. And you can see how, well, I think it's always very... I know how I would draw it, and I would put the faint stars in on the outside, but you create a sort of blurred effect in the centre because, as you say, it just becomes a milky, diffuse light. You can't really see any granulation to the core, so you're not resolving stars at the core, as you say.
Yeah, that's right. Okay, well, let's go back a couple of steps, and we go back to the bright star Arcturus. You find Arcturus by extending the curving handle of the saucepan away from the pan. That will eventually arrive at Arcturus. And if you keep that line going, that arc going, rather, you will arrive at Spica, the bright white star in Virgo. Virgo has a large curved appearance, the northwestern part of it, that's called the bowl of Virgo, and the rest of it is a bit sprawling. It's like a sort of rectangle heading off to the east. If you keep going, you'll arrive, I always describe this in a rather odd way, don't I? The two stars which sort of form a 45-degree line in the sky, which create... I know, it sounds crazy, but they do look like a 45-degree line in the sky. And those are the two stars of Libra, which are Zubanil Janubi and Zubanil Shimali, which are rather interesting stars. The upper star is Beta Libri, or Zubanil Shimali, and it's a curious star because it's the only one which has ever been described as having a green colour to it. Actually, that's not true either. You do get colour contrast. I think Antares has got a companion which somebody has described as being green because Antares is so orange.
Yes.
But I think Zubanil Shimali was described as appearing green in its own right without any colour contrast. I've never seen that, I have to say.
No, I'm not really convinced I've seen the greenish hue. Put it this way, I thought I detected a bit of green, but that's because I knew I was looking for it. I was never convinced that I would have seen it if I'd have just looked at it without knowing that it's supposed to have this. And it certainly wasn't a very strong greenish hue. It was nothing like the distinctive greenish hues of Uranus, say. It was quite subtle.
No, okay. Well, if you keep going to the east of Libra, you will eventually arrive at Scorpius, because Scorpius is the constellation right next door to Libra. In fact, Libra, the two stars there, Zubanil Shimali and Zubanil Janubi, are the northern and southern claws, which sort of gives a hint that they used to belong to Scorpius. So Scorpius is next door to the east, and of course Scorpius is a beautiful constellation of the summer months, or the summer period, and you've got that really bright star Antares, which is quite a striking red supergiant, isn't it?
It is. It's a lovely, very, very lovely star. So it's red because it's a red giant and reached the end of its life, but it is very, very, very pretty. And as we mentioned earlier at the start of this VP, the cluster Messier 4, a lovely globular cluster, lies very, very close to it. So
yes,
it's very easy to use Antares to find M4.
Yeah, well, I think this time of year, and as we head into June, that's the best time to look out for it, because once you go past that period, it disappears quite rapidly because it's headed too far over to the west as the skies are starting to darken. You can still see it, but it's just not at its best. So go out and grab it now, I think.
Absolutely.
Okay, well, I think we will now end this virtual planetarium. Thank you very much for all your information, Paul, and wishing everybody clear skies so we can go out and see some of these things.
Thanks, Pete.